In the previous video, we looked at the Taylor series and we basically got like a good foundation on how exactly to understand the Taylor series. And the goal was to eventually understand this formula. And so that's what we're going to be doing in this lesson. So, actually, from here, it's very easy. Once you know how to do the Taylor series, from here, it should be as easy as basically we already covered the sine rather. So it should be easy to do the one for the 1 plus x power n. Just imagine we have a graph. So the graph is y is equals to 1 plus x power n. And you could pause and try figure it out by yourself. If you get this, then you should be right, but we could walk through it together. So, okay, first of all, we set up our polynomial like we did over here. So we have p of x is equals to, I might need more space actually. Let's see. Let's put it like there. Okay, so a plus bx plus c x squared x squared cubed. Let's do until power 4. Plus e should be in red, e x power 4. Okay, so we have a polynomial and our function y is equals to 1 plus x power n. Okay, so dy over dx is equals to n into 1 plus x and power n minus 1. Because just the power rule, the basic power rule, you know, power times coefficient. For this one, you need to do the multiplied by the derivative of what's inside, but that's already 1, so you don't really need to. Okay, so remember, you're supposed to approximate it near 0, right? So let's plug in x is equals to 0 in this equation. Yeah, so when x is equals to 0, let's put the when x equals 0. So when x is equals to 0, then this basically just becomes 0 plus 1, 1. And 1 power any number will obviously just be 1, right? So it's going to become 1. No, sorry, n rather. Yeah, it's going to become n. So, sorry, I made that mistake. The inside is going to become 1, but you're multiplying by n in the end. So that's what it's going to be. And I forgot, when this one is approximated near 0, this is going to be 1 power n, which is just 1. So there. So, and this, by the way, is equals to our a. We already know that. This is equals to our b, because the first derivative of this would be bx plus whatever's on this side. But since all of these on the right have an x, and we're approximating through 0 with 0, it's just going to go away. So it's just going to be b in the end. Let me put that in red, by the way. B. D squared y over d x squared is equals to so power times coefficient, power minus 1 of this one, so n into n minus 1 into 1 plus x power n minus 2. And that, now we derive this one, it's going to be 2c, and the rest will have x's, so they go away. And this at 0 is going to be, because this is always going to be 1, just always imagine that we only really care about this, whatever's to the left of 1 plus x. Everything here will just become 1. So it's going to be n into n minus 1, which is equals to 2c. And then keep going until e. But you've seen the pattern already. It's starting to look more and more like this one. So let's keep going. And then d, the third derivative, n into n minus 1 into n minus 2, and then 1 plus x power n minus 3 is equals to n into n minus 1 n minus 2. I'm running out of space, I can tell. Yeah, that's it. And then is equals to, okay, now remember what we did before. This is going to end up being 3 times 2 times 1, which is just 3 factorial. So it's going to be 3 factorial d. We have A, B, C, and D. Now we're left with E to figure out. D 4y over d x4 is equals to n into n minus 1, n minus 2, n minus 3, and it's equals to, okay, I forgot the 1 plus x power n minus 3, and minus 4 now, by the way, yeah. And that's equals to, when x is equals to 0, this is equals to whatever's on the left of that, n minus 1, n minus 2, n minus 3, and that is equals to 4 factorial e. Okay, so let's reform our polynomial. A is equals to 1, b is equals to n, c is equals to n minus 1 over 2. Call it 2 factorial, I guess, so that you kind of get used to the pattern. 2 factorial, and then you reform the polynomial p of x equals to, okay, so now it's 1, let's just, I guess, yeah, let's do it in green to show that like it's a final formula. 1 plus bx, b is n x plus, and then n into n minus 1 over 2 factorial n minus 1 over 2 factorial x squared plus n into n minus 1 n minus 2 over 3 factorial x cubed. And I actually have run out of space, but let me try squeeze in a bit more. Oops. Let me just move this to the left. Okay. Plus n minus 1. Will I have enough space? That's fine. You get the point, though. This is going to end up being plus n into n minus 1, n minus 2, n minus 3 over 4 factorial x power 4. And for like fractions and negative numbers and such is going to be an infinite polynomial because these will never cancel out. But for integers, there will be a point at which like the stuff on the right will become 0. Like for n is equals to 2, you only really care about these three terms. Which, by the way, is a good rule. Like whenever you have a power, you can just add 1. An integer is a power, you can add 1, and those are the terms that you'll get, which is 2, you'll get 3, 1, 2, 3. 4, you'll get 5. 5, you get 6, so on. So yeah, you have derived this formula over here.